Good morning, everyone. So today you'll be working on lesson 8 from home, and I'm going to go through page H2-14. That is your lesson note. And then after that, you're going to be handing in 3 worksheets. So you're going to be handing in page 15, H2-15. You're going to be handing in H2-19, and then also H2-20. Okay, so those 3 sheets. I'm going to go through 14, and hopefully that will be enough to help you get through those other worksheets. And the other 3 worksheets you're going to complete, take a photo, and submit as you normally do with all of your work. All right, so we've got 2 graphs, okay, being shown. We have some scenarios, and then we have equations that we need to match with those. So the first scenario says the holder places the football on the ground and holds it for the place kicker. The ball is kicked up in the air and then lands down a field. So that should be a hint that it's going to go up in the air and then come back down. Okay, so that matches this graph here. We're trying to figure out which of these 2 equations is going to match the description and this graph here. The second scenario is a 4-wheeled cart is held at the bottom of a ramp. It is given a gentle push so that it rolls part of the way up the ramp, slows, stops, and then rolls back down the ramp. A motion detector is placed at the top of the ramp to detect the motion of the cart. So this is the distance along here from the motion detector. So the motion detector is in the spot right here. So it's rolling towards the motion detector and then moves away from it in that direction. All right, so which of these 2 equations matches each scenario? So the first equation, notice the last value, 0.95, is the y-intercept. So one of these 2 graphs has a y-intercept of 0.95. The second graph has a y-intercept of 0. Okay, so we can see that the first graph has a y-intercept of 0, so that first graph must match the second equation. And the second graph is going to match the first equation. Okay, so this point right here would be 0.95 for the y-intercept. All right, so now we'll answer the questions below each graph. What is the height of the football at 0 seconds? So at time 0, what is the height of the football? You can see that it's right on the ground, so it's going to be 0. What is the maximum height of the football? So it goes up in the air. It takes 2 seconds to get there, and the maximum height is going to be 20 meters. What is the height of the ball after 3 seconds? Okay, so for that, we're going to use this equation here. So the equation has distance and then t for time. So we want to know after 2 seconds, it's at 20 meters. Where is it after 3 seconds, right? What is that height going to be? So we're going to replace our t with the number 3 and solve for d. Okay, so there's my equation. I replace my t with the 3's. I'm going to square the 3 first. 3 times 3 is 9, times -5 is -45, and 20 times 3 is 60. And then just add those together. That gives us 15 meters. So after 3 seconds, the ball must be at 15 meters, which looks like it would match our graph because after 2 seconds, it's at 20 meters. Okay, so that's the first column. Second column, so this is the cart question. How far is the cart from the detector at the start? So at the start, at time 0, what is this distance here? And we said that was the y-intercept, so 0.95 meters. When is the cart closest to the detector? So the detector is down here, so it's the closest after 1.5 seconds, and the distance is 0.5 meters. Watch for the keywords. It says when, so we're looking for time here. That would be 1.5 seconds. How far is the cart from the detector after 1 second? So similar method that we used for question 3 in the first column. We're looking for the distance and we're given the time. So we're replacing our t with 1 second in the equation. So I've done that here. You square the 1, multiply it by 0.2, and then subtract 1 times 0.6 and then add 0.95. And you should get 0.55 meters. Okay, so those are your example questions. I do want to do one more example on one of these pages. I believe it's this one here. Yes, so the one on page H2-19, I just want to go over the method for question number 4 because question number 8 beside it is similar, and then you'll also find similar questions on one of the other pages. So I just want to make sure that you're comfortable with these types of questions. So I'm just going to show you which equation matches which graph here. So we've got a golfer takes a swing and hits a golf ball down the green. And looking at this graph here, we can see this graph has a y-intercept of 0, so it has to match the first equation. Right, the second graph has a y-intercept up here somewhere. It's going to be this 180, so that one's going to match that graph. Okay, so now that we have the equation, we want to know when is the golf ball above 40 meters. So after 3 seconds, it's at 45 meters. Right? At 40 meters, that's going to occur at 2 different times, over here somewhere and also over here on the graph. So 2 different times because the ball's going to go up to 40 meters, continue on to 45, and then come back down to 40 meters and continue on. So it happens at 2 different times. So the way we're going to solve this, we are looking for time, and we are given the distance, right? The distance is 40 meters, and we're looking for the time. So what I'm going to do here is use this equation and replace my distance with 40. Okay, so I've done that. And so we're looking for the t that makes this expression true. And the way we're going to do this is we're going to move all the terms to one side of the equal sign. So I've decided to move them all over to the left because that forces this negative 5t squared to become positive. So if you move that over, it becomes positive. The 30t will become negative, and the 40 is already there, so that stays positive. So now we have this trinomial that we're going to factor and solve for t. So you can see that we can common factor a 5 out of each of those terms. So I went ahead and I divided each of the terms by 5. And I'm left with t squared minus 6t plus 8 inside the bracket. And now we're looking for 2 numbers that multiply to 8 and add to negative 6. And those values are negative 2 and negative 4. Okay, so now I've got this nice trinomial that I factored, and I'm going to get my 2 solutions from each of the 2 brackets. All right, so if you take t minus 2 and make it equal to 0, you're going to end up with t equals 2 seconds, and then do the same thing for the second bracket, and you will get t equals 4. So that is our solution. So the golf ball will be at 40 meters at 2 seconds, and then again at 4 seconds, right? 2 seconds will be at 40, and at 4 seconds it will also be at 40 meters above the ground. Okay, so that's how you solve those types of questions. Number 8 will be similar. You're given the height of 80 meters, and it's saying when does that happen, right? So you'll take your equation and make it equal to 80, and then solve for t for your time. All right, good luck with today's work. I will be in a Google Meet again today at 2 o'clock if you have any questions and need some help. All right, have a fantastic day.